In this video, we're going to set up an example seal gap system using LMI's wireless 237, 238, and 237 Ultra Mini gauges. This setup will involve calibration and mastering using LMI's wireless utility, as well as LMI's universal gauge interface software to create and run a part file that will collect the data that we need. We start this process by first associating and calibrating our gauges. Before we begin, however, we need to make sure that the microridge USB base is plugged in, as this is the bridge that will allow the gauges to communicate with the software. Once the base is plugged in, we can open up the wireless utility and click on the Find Base Unit button. When we do this, we should notice that the green LED in the lower right-hand corner of the base begins to flash. The next step is we will turn on the gauge by pushing and releasing the Transmit button. Once we see the green LED flashing, we will then hold down the button for approximately 4 seconds until it beeps. When it beeps, we should see that the software changes over to the Wireless Gauge Information tab, and we have a pop-up here that says the wireless gauge is not associated. In order to associate it, we're going to click on the Associate Gauge button and watch the green bar as it scrolls all the way across the bottom of the window. We'll click on OK, and then we're going to press and hold the button again for about 4 seconds. And when we do this, we'll see that the red changes to green and that the grid populates with the information that is particular to this gauge. To enter our calibration and setup mode, we're going to double click on the gauge model. Now from the Edit Gauges window, we can enter the calibration by clicking on the Cal Low, and then we want to retract the plunger as far down as we can. I'm pushing it with my thumb. Hit the sample button. For the Cal High, we're going to extend the probe all the way out and click Sample. And then for the master process, I want to have a very flat surface, and I'm using our calibration verification block for this step. I'm going to take the gauge and hold it down on this flat surface and click the sample button one more time. To zero out the gauge, I simply click on the 0 button here and sample one more time. And the last step I need to do is click on the update button. When I do that, I will get a message saying that I need to exit the screen to commit the changes, so I click on OK. I will then click on the red X up here in the corner. And now I should see the green LED begin to flash red, indicating that the setup was successful and the gauge is shutting itself off. So, I've repeated the association process shown in the last section for all of my seal gap gauges, and now I need to create a part file routine for the vehicle I will be measuring. We will do this using LMI's Universal Gauge Interface, or UGI, software. Let's open up the software and start creating the routine by clicking on Create a Part File. Now, you'll probably have between 8 and 10 gauges and 4 doors per part file, but for the purposes of this demonstration, our part file will only consist of 2 doors using 3 seal gap gauges. The basic concepts presented can just be copied to however many gauges you'll be using and however many doors your particular model has. I also need to add that we will be creating as basic of a part file as necessary for this video, and there are a lot of features in UGI that I will not cover here. You can consult the manual for these details, or if you've purchased a day of training, we will cover all these details and extra features during the training session. On the left-hand side of the screen, you'll see a list of the required steps that we must go through before we can save our part file. So let's start off by giving our part file a name. I'm going to call mine 2-door compact. Now, in the part file description box below this, we can type any additional details about the part file that we feel are necessary, but for now, we're just going to leave this blank. The only other thing we need to do in this step is to click on the Browse button to select a part file location. And this will be the place where we store our part file. By default, this is in the Program Data LMI Corporation part files folder. We're just going to leave it in this location for now, so we can simply click on the Next button and go to the part file default screen. This screen is just telling us what the default settings will be in our next step, the part file gauges page. So we can skip over this. This page is where we set up the characteristic points that we will be measuring on each door. Since we only have 3 gauges and 2 doors to measure, we'll have a total of 6 points, but a more apt real-world part file will have an average of 40 to 50 points spread across 4 doors. So let's break this down column by column. The first thing I'll do is add my 6 points up here. I then click on Enter on the keyboard, and you'll see that these automatically generate. So let's go ahead and start with the characteristic column. The characteristic column is where we'll enter the name of each measurement point. For this example, I'm simply going to call these left-hand points 1, 2, and 3. And right hands, point 1, 2, and 3. The next column is where I'll enter my gauge IDs. Each seal gap gauge has a unique ID number that we will match up with each particular point on the door frame that we want to measure. I have the gauge IDs of L01424, L01173, and L01217. So I'll insert these into the row containing the point that I want to measure with each particular gauge. Now, when I do this, I'm going to be using the same gauges on the right-hand side door. So what I can do is, if I have these in the right order, I'll simply select and Control-C and then paste them using Control-V. The next column is the component column. For the purpose of seal gap systems, each component is a door of the car. So in our example, I will have 2 components. One for the left-hand side of the car and one for the right. All the components that will be measured on the left-hand door will go to the left-hand component, and all of the points that will be measured on the right-hand door will be measured on the right-hand component. I'm simply going to give this the name of left-hand, left-hand, left-hand for my left-hand points, and right-hand, right-hand, right-hand for my right-hand points. So these 3 will appear on one screen, and the right hand will appear on another screen. For the gauge type column, we simply want to select wireless seal gap for every point. I scroll down through the menu here until I come across wireless seal gap, and then click on that. Now I can do this individually for each point, or I can do them all at once by clicking on the gauge type setup underneath the Gauge Options tab on the left-hand side of the screen. I select Wireless Seal Gap from the menu, and then select the rows to which I wish to apply this gauge type. So from here I'm going to go to start at row 1 and end at row 6. And you'll see that all of them change to wireless seal gap. Now, the next 3 columns, association, calculation, and muxport, are not going to be necessary for us, so we can ignore them. The COM port, however, is very important, as this must be the same COM port that our microridge USB base is plugged into. For me, this is going to be COM6, and I can either select this manually, much like I did with the seal gap gauge type over here, or I can go back down here to my gauge options underneath COM port setup and select all 6 rows at once. When I click on OK, you'll notice that all 6 of them change. The span can be ignored and the offset can be ignored, provided that we don't have any offsets to add or subtract from the readings we'll be getting on our gauges. The next 2 columns, the USL and LSL, or upper spec limit and lower spec limit, define our limits for each measurement point. For this example, we'll leave these at the defaults of 16 and 14, though they should be defined to the tolerance of each particular point in your own part file. We also have the ability to set up cautionary limits in the next UCL and LCL columns here. However, we're just going to copy our upper spec and lower spec limits using Control-C and Control-V in here, so we will only be dealing with a pass or fail situation on each one of our gauge points. We can also insert a high reasonable and a low reasonable as well, but we're going to leave this as the default for now. The next column would be if you want to invert the reading. So instead of going from a positive to negative, this would be if you wanted to go from a negative to a positive. It's basically a polarity switch is the best way to think about this. We're going to leave this blank for now, since we don't need to worry about the polarity. And we're going to focus more on the active column. So this is where we have the gauges that are in the part file. So if I didn't want to say have this point measured anymore, I could go ahead and remove that by simply removing the checkbox, the check mark from the checkbox there. However, if you have a characteristic point in the part file, chances are you're going to want it to be active so you can measure it. The last column is frequency, and we don't need to worry about that at all since that's for a different system. So with this, we can then click on Next and go to the part file graphics screen. In this screen, we can set up a picture and put the points on the picture to where it will serve as a roadmap for our operator. For this, since I only have 3 points for my first door, I'm going to select my left-hand front door image. You'll notice this is a fairly big image. Now if I want to, I can shrink this down a little bit by double-clicking on the image and then resizing it accordingly. I can then grab the box and drag it to the point where I'd like to do my measurement. I also have the option to double-click the box and make the text appear on the right-hand side of the box instead of the left-hand side. So I place these on the image, and I noticed that that font is a little bit small. So what I can do is I can click on the font button up here, and I can increase that size a little bit so it's a little bit easier for us to read. Now, I had 6 points total in my part file, but I only see 3 here. Well, that's because we use that Components section. So I go up here to the Components tab, and I select right hand for my right hand door. And there we see the other 3 points. Again, I'm going to grab my image here, this time a right hand front door. I'll double click on it to shrink it down. And then I'll move my points to the appropriate spaces here as well. I can then increase the font size as well to 20. So now they'll match up and make it a lot easier for my operator to see what he's doing or she is doing. We can then click on Next and go to the part file inputs screen. The part file input screen is where we can create prompts that will ask the user to input specific information such as name, shift, or sequence number. We want to do this because we can then include this information in our export file, such as a text file or an Excel file, for tracking and accountability purposes. We can choose to ask the user for this information every time a subgroup begins, a part file routine begins, when a component screen changes, or before or after every data collection point in the part file. The majority of the time, we want to ask the user for input information every time they run a new part file routine. So we will choose part inputs. For the purposes of this demonstration, we want to have the user enter their name and select what shift they work on. We are going to do this using the string type and list type from the drop-down menu here. Let's start by creating a list for shift. I select list from the drop-down, click on the edit list button, give this list a name, and give the operator 3 choices here, A, B, and C. I click on OK. I'll then need to assign this input a name, which we will then call shift as well, and click on add down here in the lower right hand corner. To add the operator's name, I simply click on input name and type in the word operator. As this is a string type, the user will be able to use the keyboard to input their name and hit the enter key to advance. I'll add this to our input by simply clicking on the add button again. And now we're ready to set up the export file. The export file is what stores the data we collect as the operator runs the part file routine. This export can be as basic or complex as we need it to be, but for my specific application, I only need to see the date and time the data was collected, the user's name and shift, and of course, the actual readings themselves. I'm choosing to make my export an Excel file, which I do by simply typing .xls in the export extension field at the top of the screen. I will then give my data export a name and choose a location where I want to save that data. By default, this will save it to the LMI Corporation part files folder, the same place where the part file itself will be stored. Now, you have the option to move this anywhere on your hard drive, however, or you could even send multiple exports to multiple locations if you have a network, for example. This aids in backup and safety regarding the data that you've collected. The middle section of the screen is where I add the fields that I want to see in my Excel file. So I start by selecting header from the drop-down menu here. I then select tab as my delimiter and click on add line item. Now notice when I do this that it automatically generates an end header field. So the next step is including the static information I wish to see at the top of each column. I'm doing this by using the fixed label box here. I'm going to create a fixed label called date time, and I'll add that line. I'm going to create one called operator. I'll add that here, and I'll create another one called shift. Now, since I have 6 characteristic points in this part file, I can choose to add those individually, or I can choose all characteristics from the drop-down menu here in the field. I simply click on add line item, and then now I'm going to move this header information down here so that everything will appear between the start and end. Now if you notice down here on the export preview window, you'll see that all of these have jumped from the second line to the first line, indicating that they are now header information and will not change throughout the part file as we run it. To add the dynamic information, or the information that will change as we run the part file throughout the day, I'm going to choose all readings to get all of my readings. Click on add line item. I'm also going to choose date time from my drop down here. And then I have those inputs that I created on that previous screen. I select input operator and input shift. Now from here it's just a matter of organizing it so that everything that appears outside my header matches up with everything that's inside my header. So I'm going to start by moving my date time first, my all readings to the end, and then my operator and shift are where they need to be. If I look down here in my export view, you'll see that these line up pretty well. So I have date, time, operator, shift, characteristics, and readings 1 through 6. To add this export, the only thing I need to do is click on this button down here, and you'll see that it automatically generates this file, and this is where the file will be stored. With that complete, all I need to do now is click on the Finish button and choose Yes to save my information. From here, it takes me back out to the Universal Gauge Interface main screen, and I can choose to either edit or run the part file. Once I've created an export and saved my part file, I can then recall this part file anytime I need to collect data on that particular model of vehicle. To do this, I will double-click on the Universal Gauge Interface icon here, and then click on the Run a Part File button here. I will then browse for the particular part file I want to run, and then click on the Run button down here at the bottom of the screen. I will then enter my shift from this list and my name from the keyboard. And now I can take measurements. So the first component here has 3 points. You'll see that I have 4096 messages for each of these 3 points. And a 4096 message can mean one of 2 things. The first thing it can mean is the gauge is simply not on. To figure out if this is the case, we simply push the button on each gauge to turn them on. It could also mean that the gauge is not associated with the base, and if this is the case, you'll need to follow the steps at the beginning of this video to associate the gauge with the MicroRidge Mobile Collect USB base. Luckily for us, the gauges are already associated, and all we need to do is place the gauges on the body of the car and close the door on the car. When the door is closed, I click the sample button, and then I will move my gauges to the other side of the vehicle to sample the second component. I'll place all them on the frame of the car, close the door, and then hit the sample button again. Now, at the end of the last component in each part file, you'll be prompted with this box saying that all readings have been sampled. Please write the data now or resample. Now I'm seeing all green here for all 6 points in this particular part file, so I'm just going to write this part file. So I'll click on OK to clear out this box, and then I'm going to click on Write up here. Now when I click on Write, what this does is it writes the data to the Excel sheet that we set up when we are creating the part file. It also starts the program over. So if we have another vehicle, we can then bring that vehicle in and take measurements on it as well. So for the purposes of this video, we're going to go ahead and do a couple more run-throughs. So for this one, I'm going to be on Shift A, and my name is going to be Joe. I'll place my gauges accordingly, close the door, sample the data, move all 3 gauges to the other side of the vehicle, close the door, sample the data, and then I'm going to write the data. And then the next operator is going to be on B crew, and we'll say that his name is George. He's going to place the gauges on the frame of the vehicle, close the door, sample the data, move the gauges to the next door, close that door, and sample the data, and then write that data. Now, let's say at the end of the day I want to review what I've covered so far. So I'm going to click on Shutdown to shut down UGI. And then I'm going to open the export file. Now I've stored this in the C Program Data LMI Corporation partfiles folder. So I click on my export, and then I open it up, and you'll see that the last 3 readings here captured were Nick, Joe, and George on this particular date and time. From here, I can either upload this data into Minitab for further analysis, or I can upload it to web-based data management, or just keep it safe in case we need it later on down the line.